All right, what is up, everyone? Welcome to week 73 of Chill Kernel Hacking for Fun. Yeah, today we're gonna get into some more boot topics because that's kind of been the thing that's most inspiring me lately. So just give me a second to set up the stream. Wait, oh, that's funny. I was testing my chat widgets, and apparently all that stuff is still there in the stream. That's kind of interesting. Yeah, give me a second to post on Discord. Let everyone know. Streaming at the moment. We're live on Twitch. Yeah, so boot topics. So the last couple of streams we've been just like learning a bit about how computers boot. And now we're gonna do EFI today, and I'm just trying to see how I can how do I clear out that Twitch chat? Maybe I'll slightly change the font size in Streamlabs. Did that by any chance clear things out? Maybe it did. That's kind of funny. Let's try again. All right, that's looking a little bit better. Cool, what's up, sub? Sup? Hope you're having a nice day. We're just gonna get started in a moment after things set up. I got a new chat widget going. This stream hopefully make it a bit easier just to preserve a bit more of the chat messages in the stream. And water, let me get that. All right. As usual, we're going to reset the break timer. Anything else? Anything else useful before we dive into things? Gotta get my pop out chat all set up so I can try to monitor the chat messages a bit better. Word. Sub GH, thanks for joining. Nice to see you. All right, let's get into it. So today I want to learn about EFI, and I'm just going to sort of explain a little bit what I know about this. I mean, basically the topic is just booting. Oh wait, are there mic issues? Probably fine. Let me, thanks for the heads up. Let me see. Check, 1, 2. Is it a little bit quieter? What's up, Afnan? Let me see. I think I can boost the volume slightly. Afnan says it's all right. Yeah, I don't think I changed anything too much. audio input. You can crank the gain slightly. Hopefully that makes it a little better. I'll try to speak more directly into the microphone maybe. What's up? What's up, YMS? It's going well. It's going well. Nice to see you, Afnan. It's been a while. Hope you're doing well. I also got to ask, what was I didn't get a chance to ask, but what was that picture you posted in Discord? It was like it looked like an audio signal or something like that. Yeah, so today talk about, it was your Raspberry Pi's load. That's funny. All right, you were doing some math on the old Raspberry Pi or something. Okay, so EFI. So just for some context, we're talking about booting, and as far as booting x86 PCs go, tinkering with radio transmission and stuff, and went boom. It's crazy. Radio transmission, that sounds really interesting. All right, so graduated with my diploma, now time for bachelor's. Nice one, congrats. So I don't know how to celebrate that. We should throw a party or something. Party for off and on. That's huge. So now you're going to university, as far as I understand, for a bachelor's degree. That's cool. BIOS and EFI. So there's different ways to boot computers, and so far we've been using BIOS. And the way my general understanding of how this works is, so in the BIOS world, we got the motherboard, firmware, and then that's the thing that implements BIOS. And then you can go different ways with it. And so what we were doing at first is then we were, then there's like the bootloader, which is on disk in the first 512 bytes. And we were doing a custom bootloader for a very long time, meaning we just manually had assembly code in the first 512 bytes that fetched and loaded the kernel. And then our kernel kind of stacked on top of that. So first the BIOS, then the bootloader, and the kernel. And then what we tried doing was we tried using grub. And so instead of us writing a custom bootloader, maybe I'll put some lines here. Instead of using a custom bootloader, we moved away from that. And we tried using grub. Grub is like a professional bootloader. It's a real bootloader. And it just takes the place of this layer, basically. And then we can have our kernel just boot. We can integrate against grub. And then let me try Lemine. And this is all still in the BIOS world. And then grub and Lemine were kind of similar. But what I want to try doing now is learn about EFI. So EFI is a totally different kind of like firmware standard. And so it's conceptually at this level of the architecture. But then it affects the how things, the different layers that stack on top of it. So the custom bootloader, so basically the whole thing can be replicated over here, except the custom bootloader over here is like 512 first 512 bytes on disk. And extremely rudimentary. EFI has more features, and so the general way things work is you so as far as I understand, maybe it's kind of rare to do this, but the way it works is you generate a file system image first of all, and so there's a notion of a file system. There's a file system, and then you have specific directories that are special, and so it's something like it's like boot x64 to EFI or something like this is considered a special path, and the firmware is going to have a driver for the file system. It's going to look for this specific file, and this file is going to be the first thing that gets code execution, I believe. Not super sure on that. And as far as I know, I think these things are called EFI applications. And so it's a way more robust infrastructure for booting, whereas BIOS is like quite simple, doesn't have that many features. EFI, the whole EFI world is a lot more formalized. And so far we've been over here this entire time, and what I would like to try learning is a bit more about how things work over here. Except what I'm going to do is I'm going to stick with the actual bootloaders. I'm not going to try to implement my own custom bootloader for EFI at this moment. But the way it works is kind of similar. And actually a huge advantage of using Grub and using Limine for your boot process is because it kind of abstracts everything below it. And so once our kernel kind of starts targeting Grub or Limine, in theory, we should be able to kind of move it between the worlds and have our kernel boot on a system that's like a legacy old BIOS system. But as long as it has Grub installed, or as long as Limine is installed, theoretically our kernel should still be able to boot. And so that's sort of the idea. And so that's one of the main advantages of targeting an actual bootloader rather than trying to do things yourself. And so what I would sort of like to try to do today is explore what it looks like to boot the kernel using Grub or using Limine, but using EFI instead of legacy BIOS. Checking the chat. What's up, Digitalized? Nice to see you, my friend. Hope you're having a nice day. We were just giving a shout out to Afnan a bit earlier, who graduated and got a diploma. So that's pretty big news. Graduated today, got my papers. I'm joining bachelor's next week. So you are really wow. You're immediately starting your university degree in 1 week. No time for a break, I guess. You're just on the grind. Also, what's up, Jan? Nice to see you, my friend. Hope you're doing well. It's been a while. We should catch up sometime. Yeah, nice to see you. It is hot. It is hot in here right now. It's just, I don't know where it is where y'all are, but I'm sweating. It's a sweaty stream today. All right, so let's just see where we are at. So last time, yeah, we were using Limine, and this is what we were doing in Limine. I was trying to boot, I was trying to integrate against the native Limine boot protocol, because previously we were using multi-boot version 2, which is actually Grub's protocol, but Limine implements it. And then I found out that Limine just does not support, like the Limine boot protocol does not support 32-bit. And so we actually could not use it. And so what I think I'll just do is just, I don't know, stash all of these changes for the moment. because we are not able to use any of them. So I'm just going to stash all changes. Try Lemine native protocol. Okay, so that did not work. What happens? I try. Oh man, make clean, make key move. All right, looks like we have a build problem. As usual, what happened here? Shit. Sorry about that. What is going on? Oh, why did oh, I see. We still have this commit here. I need to revert that. That kind of sucks. Yeah, I'm just gonna revert that. Make Kimu, make clean, make Kimu. Dang. Oh wait, do I need to yeah, okay, I just didn't. Make Kimu only runs the Kimu command. Okay, so build everything, make Kimu, and now we're back. Okay, now we're back with a grub, but what I actually want to try doing first is actually booting with Lemine mode, booting EFI with Lemine. So now that things are sort of back into somewhat sane state, and I'm remembering what I'm even doing, let's bring Lemine back. Let's make again, and this should boot with Lemine and with multi-boot. So now, okay, now we're back in a somewhat sane state. To bring it back up now, so now the configuration we were using is the kernel with Lemine, and the kernel is using multi-boot v2 is our specific configuration right now. And what I want to do is learn a little bit about EFI, and the way I had in mind to do this was to look at this like that Lemine template, which actually was kind of designed for EFI actually. And crucially, it has all of the example command lines for how to set up Kimu with EFI, which I don't know anything about. Like, BIOS with Kimu is like really easy. A Kimu already comes with BIOS support, but if you want to do EFI stuff, you have to like download some, I don't know, some like other kind of interesting files, like this like ovmf.fd thing. Yeah, and apparently you like get that from GitHub or somewhere, like the build process here is cloning this from some like random account. I don't know, it's like the OS dev account or something like this. So yeah, something like that. So that's sort of what I would try to do today, is kind of get into a bit of this. What's up, Nikhil? Insane 73 weeks. Thank you. Thank you. It's just too much fun. It's just a lot of fun. Yeah, kind of the philosophy was just to have fun every single time I stream, and so far it's been just a lot of fun. So I think that's how it's happened. What's the relationship between Limine and EFI here in the boot process? So yeah, good question. So I have this kind of diagram I made illustrating what it looks like with booting in BIOS and then booting within EFI. And in the boot process for EFI, it's conceptually similar. And so there's this like firmware layer, and then Limine just implements like the layer between us and the kernel. And so a bit more concretely, what it means here is that Limine is going to, let's find the actual Limine repository, because it had these binary branches for distributions. So very concretely, Limine implements this thing called boot like x64.efi, for example. It's a special like file name. And as far as like, I don't know very much about EFI, to be honest, but what I sort of understand is that on boot in EFI, the firmware is going to parse the file system and look for this like a certain specific file path. I think it's called /boot x64.efi. We can double check that later. And so Limine is going to implement this like blob that needs to be there. And that's sort of conceptually equivalent to how in the BIOS world, Limine is going to fill the first 512 bytes on disk with some assembly that like bootstraps the system. That's sort of the interface in the BIOS world. In the EFI world, it's this sort of rather than just jumping to the first bytes on disk, there's more formalism and a notion of the file system. So Limine is going to implement this however it does, and it is going to, and that thing's going to, I don't know, like do the normal things. Actually, to be honest, I can't even speak to that. I don't know what it does. It's definitely going to at least look for its config file on the file system and interpret its config file. It's going to show that same menu, entry menu and stuff like this. And so basically, as from our perspective as operating systems developers, though, not as bootloader developers, we're just targeting the bootloader, and that gives us the portability advantages. But it's time for a 20-second break, so I'll be right back. So yeah, since we were already targeting Limine over here and getting things working, my hope was that it would be fairly simple to get things working with EFI, because theoretically Limine abstracts a lot of the details. In practice, I think there's a couple of challenges or roadblocks we might run into. The first being, will this work for 32-bit OSs? That I'm not totally sure. It might, I don't know, it might be a problem that we are on 32-bit, but I also was pretty sure EFI and UEFI work for 32-bit. So that's a little bit of an open question for me. All right. So I think the first thing I'll just do is, I just realized I have to be careful about what, I have this new like chat widget that's like blocking like a ton of the screen. I realized that a lot of the diagram was below that area. Okay, maybe I don't know, that's a bit inconvenient. Okay, but anyway, this is sort of what things look like. So I think what I'll just start with is trying to understand this example. So this is actually what we were doing last time. So when we were porting the build system to produce ISOs, we were using a lot of these instructions. The main thing in BIOS and EFI are similar and they perform hardware init, but I'm guessing EFI is the modern version of it. Oh yeah, definitely, yep. Yeah, EFI, like BIOS, yeah, conceptually they're like super similar in terms of what their goal is. It's like initialize the hardware and then hand things off to the next stage of the boot process, which is typically the bootloader. But EFI is way more modern, at least in the x86 world. EFI, I think, is less of a thing in other architectures, but in like the classic PC world, yeah, EFI is the new latest standard, and BIOS is super deprecated. Okay. So let's, so I think actually when I implemented this, like last week, since we were only using BIOS, I tried to keep it a bit simpler, and I didn't fully create images that worked with EFI. You can see here I commented out a lot of the EFI specific things, which at least at the time last week, they were not necessary. So I guess what I'll just do is I'll just bring these back in. And this is actually kind of interesting. So basically I copied these lines from, I think it was right here. This is the build target in this Limine template that produces the final ISO image. And you can see here's where I was copying and pasting this stuff. I guess I don't have echo Limine. I think I don't have that anymore. I need to real path. Limine? All right. Oh, did that not work? Oh, okay, here we go. So now I got this thing, okay. So, yeah, so what are the EFI specific things? We need to, first of all, when we're building our ISO root, we need to make sure to have this special directory. I was wrong earlier. It's not /boot /boot x64. It's EFI /boot. And then you put in these special blobs, which are the bootloader blobs basically in there. So let's do that. And then here's this complicated thing at the bottom, which I commented out, and I guess I'll just do the opposite now. So make okay, it's not ISO-dir, it's, wait. Okay, no, I need to, yeah, so this is going to be, I think these things are both just Limine dir. And then these things are going to be obster. What? Oh, oops. So this actually needs to be isodir. Right, okay. I'm gonna do make clean, start that over again. Oh, that's annoying. It builds the whole kernel again. Okay, so now I think that actually worked. So this is, so just out of interest, this is what our, okay, this is what our isodir structure looks like. We have boot, so we have EFI, boot, and then these two things. We have boot slash kernel, which is the kernel binary, and then we have boot slash limine, which contains a bunch of these limine blobs. To be honest, I don't actually know what they do, and a limine conf. And we package that up into this ISO image. Yeah, and then here's where we were doing BIOS install to get BIOS support. But I actually think if we're using EFI, we might not need that anymore. So I think that's the end. So let's see image name .iso. Okay, so now we're looking at the build target for running this example operating system. And we can see that there are two dependencies. We need to, that ISO, that's the thing we just looked at. And then there's this very peculiar FD thing. I'm a little bit concerned because I only see 64-bit architectures here in the list, but what is sort of giving me hope that we can get this to work is that it included boot IA32, which is the 32-bit, which is apparently the 32-bit boot path for EFI on 32-bit x86 systems. So I'm slightly hopeful about that. But clearly we need to get whatever this FD thing is. So let's take a look at VMF. And actually, you know what, I think I just, I thought I had a local copy. Oh, I have a local copy of limine, but not the limine C template. That's a little bit annoying. It's just a bit nicer to be in a text editor, but I think it doesn't really matter. Okay, let's look for this thing. So let's check out whatever this thing is. EDA to OVFM nightly. Nightly images of EDK to OVMF firmware for QEMU. What is OVMF? Is a port of Intel's Tano Core firmware to the QEMU virtual machine. And Tano Core, I'm guessing that is the implementation of EFI or UEFI. So there's all these different terminologies involved. So there is a spec like the UEFI spec. Assuming we're trusting this AI thing. UEFI is the spec. EDK2 is a development environment for UEFI. And Tanacore is an implementation of UEFI. As far as this diagram goes, I guess Tanacore is the thing that runs here. It's the implementation. It's like a firmware implementation. And OVMF somehow is a port of that for use with QEMU specifically. Okay. And what's the deal? We need to releases latest download something here. Okay, this is cool. So the great thing is it has OVMF code blah. Wow. There is something peculiar about ARM and RISC-V, which requires some zeros, apparently. So let's just grab a copy of this. Dir OVMF, cd OVMF, get that. Okay, so yeah, so that's our firmware basically. And we're going to pass that to our QEMU, our 32-bit, like our QEMU that implements a 32-bit x86 computer. In theory, we might have needed to do this for BIOS too, but I believe QEMU has a built-in like BIOS code. Like it uses C BIOS, I think, and that's like somehow bundled with QEMU, and so you don't need to do anything special there. But apparently, for UEFI, there's no pre-bundled firmware blob, and so I guess you need to specify one. All right. So now that we have this, seems like we just have it. So now we can proceed with actually trying to run QEMU. And I'm going to base my command off of this. Let's just take a look at what our existing QEMU command line looks like. And it's very simple. Yeah, I mean, really, the most important part is just what's right here. And we technically don't even need all of it. It's really just these two parts, I think, are the minimal one. First, it's just we're passing our image to QEMU. It's like this CD-ROM format thing, which is like a super minimal way to just pass a disk image to QEMU. And then we're just enabling the serial console. And how does that compare to this thing? So here, basically the main differences are these two lines, I guess. I might just ask AI what does onKimu command line do? Interesting. Emulate the Q35 chipset, a more modern PC platform than the default. Interesting, okay. So like, I don't really know what a chipset is, but my loose understanding is it's like what devices are available, what buses are available, something like that. So, okay, that's interesting to know. So I'm just going to copy this in here. Okay. So we have this thing, and so I guess we need to okay, I think maybe this path will work. It's just going to be it's IA32.fd. So what this looks like it does is it creates some kind of like disk drive or something. Yeah, digitalized. Yep. Still using JOS. Maybe someday we will move on, but for the moment, it is the only operating system I can use and hack on, and am reasonably comfortable doing so. So here's what we're doing. We're creating some kind of like disk drive type thing with this firmware thing as the contents. P-flash. Okay, I don't really know what that is. So somehow Kimu needs to know to use this for the EFI firmware. I have no idea how that works. CD-ROM, and let me just pass the ISO image. Let's just try it. Oh, wow, check that out. Whoa, I think it actually worked. That happened very quickly. That happened super quickly. Let's, one more time. So I'm just going to remove the os.iso. So we're gonna build, and here we ran all our commands that construct the ISO image. And the ISO image is sort of, it's just that directory structure we were seeing earlier with just the kernel in a special place, the boot IA32, the lemine.efi thing in a special place, some lemine stuff in a boot/lemine folder. We like package that directory structure up into a disk image using some special commands. And then we can run Kimu after a 20-second break, so feel free to stand up and stretch with me. Okay, so now we're on Kimu, and I guess our command line like disappeared off the screen, so we can't really see it. But what tells me that this is working is that it says UEFI32. So this is like kind of different than what we were seeing before. And I'm going to take a picture for I don't know, the memories basically. Okay, we got that working. And what does the S thing do? Oh crap. It's booting like some EFI setup menu. I think let's try that one more time. Wow, this is interesting. So here's where I don't really know what I'm doing, but it kind of connects to digitalized, to your question earlier about like EFI being more modern. One of the more modern things about EFI is that it has like settings and stuff and like GUI support, something like that. I mean we're in the command line right now, but like I think there's graphical support for like in the EFI standards or something like this. It's like the boot device, and we're seeing here, like I don't really know what menu I just entered. Internal shell. So we have Kimu DVD-ROM. That corresponds to the CD-ROM OS ISO thing. That's our image. And then the hard disk, I'm just going to go out on a limb and say that corresponds to this drive device that we're passing, which is this like firmware blob. So I actually, to be honest, I really don't understand how this, like why the firmware blob is on a drive, because in my understanding of how this all works, the firmware layer, which is either the BIOS firmware or the EFI firmware, that's on the motherboard. It's not on like a disk of drive. It's in like some flash memory on the motherboard itself. So that's a bit of an open question for me. But anyway, we have this menu or something. And we can get out of it by pressing escape. And we can do the normal thing and edit the configuration with our command line. I'm going to press escape again just to get out of it, and we can just press enter to boot. And it looks like that just totally worked. Yeah, like our kernel, like these are all the log lines from our kernel. We're still using multi-boot 2. But it seems like that is fully functional, and so it's fully functional that we have a multi-boot 2 kernel booting off of Limine, which is booting off of, technically it's boot XIA32. Actually, no, this is these are the same thing. Booting off of whatever layers below it, it's like this OVMF thing would be the layer below it. So that's kind of nice. I don't really know what that actually gives us. It's just sort of another way to boot the OS. But I suppose it gives us access to a bit more services, like boot services, if we wanted to use EFI services. Technically, that's sort of Limine's job is to interact with the firmware via EFI services to do stuff, and the kernel shouldn't really know anything about that. And so that's why it kind of doesn't matter which one we use. But it is just cool to learn a bit more how actual modern booting works, rather than just staying in this like BIOS world, like which is decades old. Although it's a little bit annoying that it requires like all this setup, like you need to download that weird sketchy.fd file, which I don't understand. Yeah, so I'll just make a commit, I guess. I also just commit that into the repo, who cares? Make a commit, whip EFI booting with lemine. All right. So what do we do from here? Is that really all there is to it? I mean, I feel like I at least want to read like a blog post or something explaining this. Or maybe just Google how to boot Qemu EFI OVMF. Are there any good posts about this? Just, okay, part 6, that seems comprehensive. I'll just quickly skim through what other people have said about the topic. So we were using some random pre-built binary from this like OS dev 0 thing. Which is quite handy. Okay, not really trying to get into those details at the moment. P-flash. Okay. Oh, bummer. Do I need a... Okay. Qemu by default uses cBIOS. And here's that. So here it's talking a little bit more about how you actually pass this thing. The important thing is the drive is of type P-flash and read only. Okay, pretty short article. Oh, from ChatGPT. So this is kind of interesting. They do it a bit differently. Oh, what? These files come with Qemu. And look. Wow, this would be quite interesting. If Qemu comes with its own... Okay, I don't know. If we didn't want to use this random binary blob from this random person on GitHub, maybe we could use the ones that are distributed with Qemu natively. That might be cool. But I guess for the moment I don't really have anything else I feel like doing here. Like that was fairly straightforward to do, and all it really involved was adjusting the build scripts to properly populate the disk image with the appropriate components. One thing we could quickly try is actually not including this x64 thing, because I think we totally don't need it because we're not on 64-bit yet. So I'm going to remove this. I'm going to build again and run it, and everything still totally works. So so yeah, that's kind of interesting. Yeah, and so adjust the build process to prepare an EFI compatible image. And then just like slightly adjust the Kimu command line to okay, step 2 is download this random thing, and then step 3, just slightly adjust the Kimu command line to tell it to use this FD thing. I want to ask, what is this P flash thing though? Kimu P flash. There are 2 ways you can either pass the P flash or drive P flash. What is P flash? Also, this Reddit thing looks really good. How to boot in EFI mode. So this person is using the strategy we're using. And apparently these other people are passing it with -BIOS. Is there any docs on this? Kimu command line docs. I don't. -BIOS, does it say anything? Okay. Set the file name for the BIOS. Parallel flash image. Okay. It doesn't really say too much about what this is, but the way I think it works is that if Kimu sees it, it prioritizes it and just assumes that whatever is on this P flash thing is like the motherboard flash firmware or something like this, and use that instead. All right. Huh, okay. Well, that was a bit easier than I thought. Not totally sure what to do now. I mean, I have some other ideas for other topics, but anything else cool we could do with EFI, or is that really it? Maybe we could, I'm just kind of curious what this like menu was. So we boot into Limine, and we have the firmware setup. Oh shit. Okay. What? Press enter, select boot device, escape. So I don't know what I think. Like, what is EFI firmware setup? Wow. This is like. Like some settings menu or something. So what we're seeing here, I think, like, this is not Limine. I think this is actually implemented in that like OVMF blob thing, actually. Can I get out of it somehow? Press escape enough times. Kind of stuck. Oh, wait. Oh, wow. Okay. This is, it's just like really messing up because we're doing this thing over the serial console. So what I will try to do is say I'll comment this out and I will rebuild and let's just run this in the actual in like the real VGA console. Now we're in, like, I never use this, but we are in like the VGA. Oh shit. I accidentally booted the OS, which I did not want to do. What I want to do is I want to press S. Now that is interesting. I don't know if I can make this smaller, actually. This window doesn't seem to support resizing it. I just hope my chat thing is like not too much in the way here. What's up, Kevin? Or what's up, it's me, Kevin. What's your profession? What type of programming are you? Currently, I work as a software engineer in the music technology industry, and I work on embedded systems. Formerly, I was a cybersecurity engineer also. Not a weird question. I want to be a front-end developer, and I'm a beginner. That's awesome. Cool. I got to be honest, we do basically zero front-end development here on my streams. But if you want to be a front-end dev, that's awesome. I think you should go for it. Yeah. But that's my background. So check it out. We have this interesting menu. And yeah, my understanding is that this comes directly from the boot, like the EFI firmware. It's this OVMF thing. If we click enter here, wow, this is like kind of cool. We boot into some kind of settings menu that's really at the UEFI level. It's like super low level. It's not even at the bootloader. It says directly, and I can navigate it with my keyboard. I don't see a mouse, so I guess my mouse got eaten up. And device manager, RAM, is like quite sophisticated. I don't know. Compared to BIOS, this is very featureful. YMS. Actually, I did wrote the bootloader. Very cool. Nice. Okay. I don't know if there's anything cool to really check out there. What if I press continue, that leads us back here. If I reset, what does that do? That reboots the machine or something? That was interesting that there was a Core logo there. And what about, like, so if I boot into these two things, I expect things to break. So the DVD-ROM is our kernel. So, and interesting. So that, this brought us back to Lemine, which is interesting. So the DVD-ROM has the Lemine image installed onto it. What about this hard? This hard disk is the firmware, and that doesn't do anything. And the EFI internal shell. Huh. So now we get this shell to use, help. And we can we can do some stuff here. I have no idea. I just typed exit to exit that. So device manager, platform configuration. RAM disk. Huh. Boot maintenance, boot options. Change boot order. Yeah, I don't know. This is just interesting to kind of play around with. So there's just a lot of infrastructure available to you, apparently, if you operate in the EFI world. Console options, COM attribute setup page. No idea what that is. Console output mode. Boot from file. Continue. Here we can see the Q35 thing. I guess I don't have a mouse. The Q35 thing that corresponds to this like chipset parameter that we were passing to QEMU. Okay. So I guess that's like kind of it. Yeah, and now our kernel boots. And it panics because that's what I had it configured to do. Yeah. Going to drop this change. So what to do from here? Otherwise I would just continue with my list of random stuff I'm interested in, but it's sort of rare that I finish a little bit earlier than I was thinking. So basically my idea, it's a totally different topic, but working on C++ support for the kernel would be very interesting to me. Porting to 64-bit is also a topic kind of on my mind. If we ported to 64-bit, then we could use Limine, the native Limine boot protocol, which might be interesting. Yeah, otherwise, I don't know if there's anything else interesting with EFI. If anyone has any ideas, I'm totally open to that. I'm just gonna paste this link. All right, 20 seconds. Just brainstorming anything while I'm just in the EFI topic. Anything else that would be interesting to explore. I guess the reason it's fairly boring is because we are targeting like Limine. One thing that might be interesting is to try using Grub, actually. So we were using Limine, Limine on EFI. But I'm sort of curious what it's like to use Grub with EFI. And I'm not even, I kind of want to try that. So what would that look like? So if we wanted to use grub instead, some of this will stay the same, some of it will be different. We will need to, yeah, like instead of like these two things, will need to be grub instead. There's a whole bunch of these things too. How did we know to do that? Right, so that all came from here. Maybe it's worth how to grub EFI Kimu. Yeah, YMS. I'm pretty new to this stuff also. This person's saying just add BIOS and you're good to go. This doesn't work because BIOS is OVMF is not BIOS. It does work as long as you use a combined single file version. Opie talks about this thing that is shipped with Kimu, which is not such a file. Complicated. Wow. Okay, but that's not really what I was trying to do. Where was I? I was following some grub instructions earlier. Let's see if I can find those. About this. Oh, sorry about that, YMS. Maybe you can like break the link with some spaces and still post it. Okay, it might be time for using AI to help. So I want to boot boot using how to boot grub on QEMU in EFI with EFI. I already have the ovmf.fd file. Let's search for this. So I need to get a pre-built grub boot IA32. Maybe I can search for that. Grub pre-built boot IA32.efi. This first one looked decent. So is that just it? Is this like this grub? What? Oh, interesting. So maybe that would be pretty cool. Dang. Sir, local seller. It's like hopped homebrew seller grub. These are modules. Whoa. This is one way to do it. QEMU with EFI. So I'm gonna, this is sort of like more points for Lemine. It was quite easy. Like Lemine had the binary builds all prepared. Making, and I don't know if QEMU UFI boot grub. Let me go back here. Grub, make, rescue. Stuff, grub, make, rescue. How did I know? I'm just trying to, like, I wish I recorded what instructions I was following. Maybe it was these instructions. Grub, make, rescue. What does this do? Program generates a bootable. Okay. Does grub, make, rescue generate an EFI bootable image? Everyone on the internet is asking this. I guess maybe let's just try. So going back to the grub instructions, here was, like, here's the basic way I was generating a grub image just using the grub make rescue tool. And what happened since then? Okay. I'm just trying to figure out the best way to, maybe I'll just manually try to get some of this stuff back. So these were the very simple commands we needed. So maybe it's a little bit of a long shot, but maybe there's a chance that this grub make rescue thing just does everything. Meaning like maybe it automatically creates the EFI directories and stuff like this. I'm like a little bit skeptical of this. Yes, can generate EFI bootable ISO. As long as it finds the necessary grub EFI files. Let me just try. What type of file? And how? How can I list the contents of a file on macOS? Is there maybe a command line tool? HO. Do I need to mount this thing? I would like to avoid doing that. I'd rather install this thing. Let's try that. So I want to examine this ISO and see what grub make rescue did with it. ISO info -l -i object os.iso. But wait a second, why is there okay, so clearly there's a lot of stuff that got put into this thing actually, which is cool actually. It's good to know that grub is putting stuff in there, but why is there any Lemine stuff in there at all? 20-second break, be right back. All of this should have been commented out. Oh, I guess I need to delete the ISO dir. That would be why. Now let's make again. Okay. And now we can ISO info this thing. And we can see a bunch of, grub did put a bunch of stuff into this thing, but unfortunately it did not put like the EFI files into it. What's up, Useless? Nice to see you. It's going pretty well. Running into a couple challenges at the moment, but earlier we had a bit of success. We were able to boot using EFI with the Lemine bootloader, and that was fairly straightforward to get going. What I'm trying to do now is actually get grub, like tried using grub also with EFI, and it seems a little bit less documented somehow. I also didn't spend too long reading the forum posts but yeah, I don't expect this to work. So we use the grub make rescue program. If I just search grub though, homebrew. Yeah, like, so this is the, oh wait, not, this is super recent. So I'm curious what kind of packaging. Wait a second, is this even grub? Okay, grub. Yeah, no, I don't think, disable EFI. Yeah, grub, I don't know. I sort of like the idea of using grub since it's such like widely used technology. Grub. EFI? No EFI. Cannot find how to create the media. This is exactly what yeah, no good answer there. Check this out. Installing grub depends on how the system's meant to boot. This is so complicated. Grub install. So what's the deal with grub install? Yeah, I don't know if this is worth spending too much time on, man. But it's interesting to see how we would, like, I feel like I'm sort of just using a bunch of random resources. So this is sort of... So here are some random links. Interesting. I could maybe try to use that. I still think one of these I could just try to like do it myself, like download that random, go to that link that I just saw, download the boot x64 thing, package it into my thing, but I would expect there are just like a lot of other problems I might run into. So I think yeah, these tutorials might do better. But this is super low level. It's like doing so much disk stuff. Like formatting the disk. Can I please? Okay. This is crazy. It's very low level disk. Do I have grub install? Install? It looks like I don't even have grub install. Well, this is a pretty good link at least. Just curious, what does ChatGPT say? Okay, I'm gonna ask ChatGPT just in case it's different from Copilot. I'd like to boot my hobby kernel, hobby operating system with grub on EFI with QEMU. It's using for 32-bit x86. What should I say? How might I do this? I want to create a bootable image file with grub installed into EFI boot i32 EFI, and then have my kernel in boot and the grub config in boot grub or something. like this. How might I do this? What does it say? Is this an apt package? Wow. Okay. So, bummer that I'm not on Linux right now. And it's using grub make image. Create fat formatted. Ooh, wow. Why is this so much more complex than Lemine? I wanna... I'm just gonna ask it, why is this so much more complex than Lemine? Like, with... I can do the... with the Lemine bootloader, all I need to do is this. Can I tweak this to work with grub instead of the complex instructions you gave me? This is incredibly complicated. Wow. Add grub. I'm on a Mac. Where can I get a pre-built boot x60 IA32 EFI for grub? Wow. So I could like muck around with this apt package. I do not want to build grub at all. Okay, maybe I could try using that random link someone posted. Here. Okay, these are only for 64-bit, unfortunately. So I guess this thing is the main option. The question is Linux. So I do have Docker. Dang, Docker is trying to pop up. Docker. Container is not running. Docker start. Yeah, okay, I don't know if I'll be able to do this in a timely manner. So I can get a Linux environment, but do I have a shared file system? I don't think so, but maybe I can ask. Here's my Docker command. How can I make it have a shared folder with my host? All right, I'm gonna kill the palm tree. Show the current directory. Root. Maybe we can try this. Does this work? It's already in use. Docker stop, yeah. Good, that seems to be hanging. Okay. Okay. Stop. Wait, so now does that work? I stopped the container called VM. Can I restart it with a shared folder? Oh, wow. All right, you know what, guys, I don't think I will be able to do this in the remaining couple minutes I have on stream today, so I think I'm going to start to wrap it up, but this was an interesting effort, at least. It showed that it was pretty it was pretty easy to get Limine with EFI working. It was pretty easy to get grub with BIOS working via grub make rescue. But then it turned out to be very challenging to get grub with EFI working because there don't seem to be pre-built grub binaries. Maybe if I was on Linux, that would be easier to access a grub pre-built binary. But it seems like to do that, I would need to rip one from the apt package. This package contains a version of grub that has been built for use with EFI i32. Yeah, it seems like I would need to rip one from here and then potentially put it into the disk image, but it seemed like there were just so many other steps it was telling me to do, which I didn't really understand. It was basically saying grub make images. No, wait, does this produce the EFI binary? i6 make image. So I do not expect this to work at all. What's up, guys? What's up? What's up, Trong? What's up, Zero? And what's up, Stefan? Nice to see you. Does this work? Does this work? I'm trying to boot with grub with EFI, and it's being crazy difficult. Yeah, interesting. Grub make image is like not working on Mac, it seems. It's trying to access files. Oh, interesting. Well, I was trying to access a file, it's not there because I am using a 686 grub for some reason. If I do 686 EFI, does that do something? No, unknown format. So who knows what that was. But in theory, like, what does this even do? I think this is actually just hallucination. Make a bootable image of grub. Yeah, this is complicated. Grub make image versus grub make rescue. It's a top question I have. Creates a standalone grub EFI or core image binary. So this is kind of low level, it seems. But is that really true? This thing says that it makes a bootable image of grub, which sounds kind of different than what this is saying. EFI directory. So Trong, sorry, you asked, may I ask what would be the steps to start learning OS kernel programming? I have some resources I can link you to. My advice is to follow some of the free online coursework that's available on the internet. That's something that worked pretty well for me. Also, holy crap, I just realized my camera is like frozen. Is that really the case? Wow. Let me maybe switch to a different camera. All right, crazy. Yeah. Yeah, I think I personally, that's the way I learned, is I just used free online coursework. And that would go also for you for Z10. Whew, man. Yeah, this is intense. So Stefan, I have been exploring EFI this stream, and what I'm trying to do, or was trying to do, because I'm probably about to stop soon, is I've been trying to get my OS to boot with grub on EFI like mode in QEMU. Because I had grub working previously with legacy BIOS, but I've been trying to get things booting with EFI. And I was pretty successful with doing that with the Limine bootloader. That just had some good examples of how to get that set up. In particular, it just has this example C template, which is pretty good, and it just shows you everything you need to do. You just need to. It also has some really nice pre-built binaries, which were very useful for these EFI files. And so this was pretty straightforward to do. And then I thought it would be interesting to also replicate that with grub and use grub as the bootloader on EFI. And this is proving to be significantly more difficult because there aren't really pre-built binaries, at least not that, like, I'm also on Mac, which is complicating this quite a bit. And so if I was on Linux, I could maybe use like the apt repos, which have something like this, but I can't access that for the moment right now. And I don't have the pre-built binaries. And I'm also not really finding good documentation on doing this with grub. There's some blog posts. Yeah, you should try building your own EFI application and booting it. That sounds hardcore. Yeah. Yeah, that sounds pretty hardcore. I'm not that like interested in bootloader development really right now. That's sort of the whole point of getting the pre-built binaries. GNU EFI or NYU if you can avoid all the tooling struggles and just learn EFI. Interesting. Let me check I've never heard. I'm pretty new to EFI, so don't really know too much. Okay. So they're like just development environments for developing EFI apps. I see. What's NYU EFI? It's like GNU EFI, but better. Yeah, but this person is everywhere. That's pretty cool. Interesting. Well, I guess this is relevant for them because when they like Lemine is an EFI application, so they actually maybe they even use this to build the Lemine EFI app, I would guess. Interesting. Yeah, that would be cool to check out at some other points. Interesting. The standard way to do EFI dev is with EDK2. Yeah, EDK2 is a large, complex environment with its own build system. And GNU EFI or whatever lets you do this with GCC. That's cool. This EDK2 thing seems really industrial strength. It's bigger, more features. Full implementation of the spec. Okay, I'm confused by that. I thought EDK2 was a development environment. And I thought Piano Core was the implementation of the spec. It contains the OVMF package. It has ARM package and blah, blah, blah. Is the EFI library and build system. That's wild that it has its own build system. Does it really? All right, well, I'm gonna consider today half win, half failure. So the win was pretty easy to get Lemine working with the kernel with EFI. Failure was, it was kind of hard to get Grub working. Maybe off stream I will do a little bit of more research, like just like reading some forum posts or something like that about Grub, just because I saw something about me is like wants to use Grub just because it's like very industrial strength. But it is yeah, it's a little bit difficult to work with apparently. So yeah. All right. Anything else to do today? I think, or maybe it's time to wrap it up. How's the working tree looking? This is all just random stuff I was trying. I'm just gonna drop this, maybe just for fun. Let's try just let's just look at that boot up. Yeah, just to end off the stream, check it out. This is Lemine booting in EFI mode, and then bam, our 32-bit multi-boot kernel boots off of Lemine in EFI mode. Cool. All right, y'all. I think that's gonna be it for today. Yeah. So thanks for tuning in and watching me struggle and read and Google various things. But at the very least, we got this working. So I'm gonna post my Discord if it'll pop up. Feel free to join that, and I will see you next week. Peace. Have a nice one.